Hello beautiful people and welcome. In this video we are talking about complex solutions when solving quadratic equations. Now what is a complex solution? Now a complex solution, I'm going to shift this up just a little bit, or a complex number, it is a combination of a real and an imaginary number combined. Now let's bring this back up here. What's an imaginary number or imaginary unit? An imaginary unit is indicated by the letter I. Now, typically when you write it, you want that I to be slightly curved with a little tail, just like that. Now, I is equal to the square root of -1. But wait, we can't take a square root of a negative number, and that is why the I represents an imaginary number. Now, because I is equal to the square root of -1, I squared is equal to 1. And that is because if we square both sides, we have a secret index of 2 here. The square root and the square, they undo each other, so you're left with I squared is equal to -1. Now this is very important when you are dealing with square roots here. And let's apply the product property in example 1. So in example 1, we have the square root of 25. Now, we know that if it was a positive 25, we know the answer is 5. But in this case, we do have a negative 25 underneath that radical. So let's apply the product property and say, hey, we can do a -1 times the square root of 25. Splitting it up like that allows you to identify the imaginary unit, which is the square root of -1, and it also allows you to simplify the square root of 25. Now the square root of 5 is 5, and then this square root of -1, we know that square root of -1 is equal to I, so we have I. Now, if you leave your answer like this, that would be considered incorrect format. So make sure that you write your I after your number, just like if it was a variable. So we have 5I as your answer. Let's do another one. Let's go ahead and split this up just like before. So we have the square root of -1 times the square root of 72. Now the square root of 72, I don't believe that's a pretty number because the last one that I can think of is 8 times 8, which is 64, and then 9 times 9 is 81. So 72 is not a pretty number. So I'm going to choose to check on my calculator here what perfect squares go into 72. So a perfect square is, for example, 4. 4 and 18 work. A perfect square is 3 times 3, which is 9. 9 and 8 works. And then we can see if, what's the next one? 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16. 16 is 4.5, so that doesn't work. 5 times 5 is 25. 6 times 6 is 36. Maybe 36? 72 divided by 36. And that's 2. So you can see that 2 is the smallest number we can multiply by. So let's separate this out one more time using the product property. So -1 times. So instead of writing 72, I'm going to write 36 times 2. And why is that? That's because 36 times 2, let me highlight that for you. 36 times 2 is the same thing as 72, the square root of. And then we're going to simplify this further. Well, I know that the square root of -1 is I. I also know that the square root of 36 is 6. And then I also know that the square root of 2 is not a pretty number. It's an icky number, some sort of decimal. So that means you're going to write your answer like this. You're going to write your number first, then goes your letter I, then goes your radical, which in this case is the square root of 2. This here is your answer. Now, one thing I want to point out is when you're talking about imaginary numbers, complex numbers, It is a combination, like I said before, of a real value and an imaginary. Now, I did put in quotations pure. If you have just bi, just this alone, with no a value, that is when it's considered a pure imaginary number. Or you can just say pure imaginary. Now, the number in front of I, this number right here in front of I, this is your imaginary number. So, for example, if this number was 3i, 3 would be imaginary. Let's move on to more examples. Now, we already used the principal square root of a negative in our two previous examples, but why does that work? Well, that works because of the product property for radicals, and what that means is you can split up into multiple things and get that -1 square root of -1 by itself. We note that that square root of -1 is equal to I, so therefore you have I times your radical, in this case the square root of b. Now, just like I said in the previous, 10 seconds ago, 2 seconds ago, this right here, because I and b are alone, this would be called your pure imaginary number right here. So let's go ahead and do the square root of 25, -25, excuse me, one more time. I'm going to change colors here for you. Using the product property, we have -1 square root times the square root of 25. That means I have I and I have 5, which means I have 5i. Again, make sure your I is a little bit on the twirly side with a little tail there. Square root of 4, we have square root of -1 times the square root of +4. Square root of -1 is equal to I. Square root of 4 is equal to 2. 2 times I is 2i, and you have your solution. Moving on to example 3. Now in example 3, we're going to be foreshadowing the next video that I'm going to be putting out, which is adding, subtracting, multiplying the radicals. So in this example, we're just going to slow it down just a little bit. So for this one here, the square root of -25, we already know what that answer is here, which is 5i, but I'm going to redo it one more time. Square root of -1 times the square root of 25. We are now adding that to the square root of -4, so I'm going to split that up. Square root of -1 times the square root of 4. We already know what the square root of -1 is, and that is I. We already know what the square root of the square root of 25 is, which is 5. I'm going to bring down this plus. We already know what the square root of -1 is, and that is I. And we already know what the square root of 4 is, which is 2. I'm going to rewrite that in proper format. 5i plus 2i. Now you're treating it just like combining like terms. You have 5 i's and 2 more i's. Therefore, you have a total of 7 i's. Let's try multiplying. One more time. I'm going to skip this step here because we have the same radicals. So this one here is 5i. This one here is 2i. How did I do that? I followed example number 3 into our simplifying, except now instead of adding, I'm going to multiply them. Now when you're multiplying, this is where it's different than example 3. What you really have here is you have 5 times I times 2 times I. So you have 4 things that you are multiplying. And just like when you have x's and y's, you're going to combine the things that are the same. So I'm going to combine and multiply 5 times 2, and I'm also going to combine and multiply I times I. Now 5 times 2, everyone should know that is equal to 10. I times I, just like with x's and y's, that is going to equal to I squared. Now we have one more step, And I'm going to bring this paper down just a little bit. Here is it on here? It is not. So I'm going to go back to the beginning. This is where we're going to use this right here. I squared is equal to -1. So when we get I squared in example 4, this right here is going to be equal to a -1. Now when you are replacing I squared with -1, put it in parentheses so that way you can keep track of that negative. And so now you have 10 times -1, which is -10, and -10 is your simplification of the square root of -25 times the square root of -4. Let's go ahead and move on. We're going to move on to solving quadratic equations. Now we're going to be doing this in 3 different methods, taking the square root, quadratic formula, and completing the square. Hesitated there for a moment, I forgot what it was called. So taking the square root, we are going to isolate this term here by getting rid of that 25 on both sides. And mathematicians, we're a little bit lazy when it comes to naming things. So when we're naming something taking the square root, guess what we're doing? We're going to end up taking the square root. So I have 9x squared minus 25. Now originally, when we were taking the square root and solving quadratic equations, we said, hey, if this number is negative, you can't take the square root. It's not possible. Well, now with imaginary numbers, it is possible. Your answer is just going to be a little bit more imaginary. So I have x squared is equal to -25 over 9. I'm going to take the square root of both sides. Now remember, when you take the square root, when it's not given to you, you are taking the square root. You always add the plus or minus. Super duper important for you to remember that information. I'm going to highlight that for you. You have to take plus and minus. I'm going to use our property to separate this out. I believe it's the quotient property. So I have negative. You can put the negative on top or bottom. It doesn't really matter. So let's do -25 since we already know what that is. And -9. Ooh, +9. We want only one negative because the fraction itself is negative. We want the negative either to go only on top or only on the bottom. In this case, I put it on top. I'm going to shift this up here. We know that -25, the square root of -25 is 5i. How do we know that? We already did that a few times in this video. Here is example 1 here of the square root of -25, where we separated -1 square root times the square root of 25 and found 5i. And then in the denominator, we had the square root of 9, which was 3. So you can leave your answer like this if you want. You can also bring out the numbers, so 5/3, and then write I next to it as like multiplication. You can. Just make sure that you understand that this is plus and minus because you took the square root. Moving on to example number 2. In example 2, we're asking you to solve the quadratic equation by the quadratic formula. You have to have the quadratic formula memorized. The quadratic formula is the opposite of b, or negative b, plus or minus the square root of b squared minus 4ac divided by 2a. So what is your ABCs? Your ABCs consist of your coefficients. So here's one coefficient, here's another coefficient, and here's your third coefficient. Now make sure, note that for this one and this one, your B and C, I did end up taking the symbol in front of it. So when you take the symbol in front of it, that's going to be your ABC. So this is your C. All right, and at this point, you kind of just plug and chug, plug in your values. I typically like to rewrite the formula, but instead of writing your ABCs, your letters, I like to create empty bubbles, empty parentheses or groupings here, and then plug it in with my numerics. So I have B. B is -2. B is still -2. A is 3. C is 4. And A is 3. I'm going to simplify this one here and this one here, the denominator. So I have 2 plus or minus the square root of, I hesitated there for a second, negative 2 squared, that's 4, minus 4 times 3 times 4, all divided by 6. Now using your calculator, you can evaluate what's inside this radical here. So I'm going to do 4 times, on my calculator, I'm going to do 4 minus parenthesis 4 times 3 times 4. In parentheses, I'll show you that here, just like that. I'm going to press enter. Now that gives me let's bring it down here, 2 plus or minus the square root of 44. This is being divided by 6. Now, based off of your discriminant, if you remember that, if you recall that from an earlier lesson, based on the discriminant being negative, that means there are no real solutions. That means our solutions are going to be complex numbers. So let's go ahead and separate this out. So I'm going to say 2 plus the square root of negative 44 divided by 6, and 2 minus the square root of negative 44 all over 6. Now I'm running out of space. I'm going to do this on a separate sheet of paper. There it is. All right, so with 2 plus the square root of negative 44 divided by 6, we'll work one at a time. I'm going to use the product property, and I'm going to separate negative 1 times the square root of 44, still divided by 6. Now I'm going to try and simplify 44. Maybe I can separate, maybe I can pull out a number. Like for example, I'm looking for perfect square. So a perfect square is like, for example, 4. 4 is a perfect square. So I'm going to use the product property one more time. So I still have this square root of negative 1. So I'm going to separate 44 into 4 and 11. Now again, you can use this because we have a special property for it. It's radicals, it's square roots, but it's still multiplication, and multiplication is just perfect for us. So let's go ahead and simplify this out. I have 2 plus, we know what this is. This is I. Then we have the square root of 4, which is 2. It's still multiplication, so make sure you are aware of your symbols. And then the square root of 11, that's an icky number, so we're going to keep it. All of this is still divided by 6. Now, one thing you can do to simplify your answer further is to separate out the terms. So in the numerator, you have a binomial. I'm going to rewrite this one more time to show you. I'm going to switch the position because we want number, then letter. Root 11. We have a binomial. We have a 2. This is one term. And then we have the positive 2 times I times the root of 11. That's the second term. So we have 2 terms. So we can split this up as to 2 divided by 6 and 2 times I times root 11 divided by 6. And the reason you want to do that is because now you get to simplify that 2 and 6. So 2 goes into 2 one time, 2 goes into 3, 2 goes into 6 3 times. Still here, we can do this because we no longer have addition, subtraction. We only have multiplication, division. So I'm going to say 2 goes into 2 once, 2 goes into 6 3 times. Simplifying this out one more time, I have 1/3 plus I times the square root of 11 divided by 3. Now this is one of your answers. Remember, this is just the plus portion. We're going to do the minus portion. So I'm going to rewrite that. That's 2 minus the square root of negative 44 divided by 6. Now doing this one the second time around, we already know that we can pull out a negative 1. We also can pull out a 4, and we can also pull out an 11. All of that is coming from the square root of negative 44. We also know that all of this is going to be divided by 6. And we're going to simplify this out to say that we have 2 minus, we have a I, right? The square root of negative 1 is I, times 2, which is the square root of 4, times the square root of 11, divided by 6. Rewriting that one more time. We have 2 minus 2i. Again, I'm switching the position, times the square root of 11, all divided by 6, and I'm going to separate that out one last time to simplify our answer. Dividing by 2, so we get 1/3 minus I times the square root of 11 divided by 3. So these are our two answers. Now again, these answers are equal to your x values, and these just happen to be imaginary x values. These are complex numbers. All right, beautiful people, that is it for this video. Thank you so much for watching, and I will see you in the next one. Bye!